Hello students, welcome to Tej Academy. I hope all of you are done well in your English exam. Ellaru chennagi madira anta ankondidini. So next exam in focus is physics. So focus is on the physics because it is a science subject and it will be the first of science subject that you will be writing. So in order to help you people from Tej Academy, we have come up with a passing package. So 40 plus marks from the board exam. So if you people are in the last minute revision and if you are willing to score a passing mark in physics exam, this video is exclusively for you. And if you have prepared all the topics and you are ready to write any questions from that, still you can use this video as a reference for revision. So those who are willing that I need to get 40 plus marks a score, you people can watch this video exclusively. And we have planned this package in the following manner. So we are divided into three parts. Part 1, 2 marks. Part 2, 3 marks. And part 3, 5 marks. So the part 1 video, which will be based on 2 marks, will be uploaded today. Part 2, 3 marks will be uploaded by tomorrow 11 o'clock. And part 3 video for 5 marks will be also uploaded by tomorrow evening, so that you will have enough time on day after tomorrow to revise all this what you have done tomorrow. And it will be very useful video for you to learn and then get benefit out of that. Before that, please subscribe to our YouTube channel, Tej Academy. And if you are interested in availing all the PDF notes of the materials that we are discussing through our videos and exclusive materials that have been prepared from Tej Academy, please join our WhatsApp group or Telegram channel. You will be able to access all the PDF files related to the assessments, questions, material, content, everything. And you can also download Tej Academy app from Google Play Store, where you will be getting access to all our videos as well as the content whichever is provided by us. So if you subscribe, you will get the videos at the earliest as soon as you upload it. So please do subscribe to our channel. And also there will be many students who may not be knowing about our academy, your friends or your relatives, and it will also benefit them immensely. So I'd like to request the people to share this video to as much as students as possible, so that everybody will be able to get the benefit from this video classes. So please do subscribe and also share it with your friends and family. And additional information what I would like to give is, there is a National Common Entrance Test NCET, which is for the admission to BA CED science based course, BA ED arts based, and BCom ED, that is commerce. So you have a provision for science, arts and commerce, which means students in second PU who are reading science, arts and commerce, all the three majors, they will be able to benefit out of this NCET examination. And you know, this year onwards, so many IITs, NITs will be providing this course, ITEP, Integrated Teachers Education Program, along with RIs which are already offering this course. Applications have already started from 12th February itself. 10th March will be the last date for this. So we don't have much days for application. So if you people are interested, please apply to this examination and also inform anybody who is like-minded to join these kind of courses. And for those who are joining to those who will be applying, Tej Academy has exclusively brought a batch, Tejas batch, for the purpose of preparation for this ITEP examination. So we have already commenced this online tutoring for students from February 20th itself. And if you are interested, you can join this online course and you will be able to get the benefit of exclusive video contents, and also you will have live classes and you'll be having test series beautifully planned, exclusively done, and then based on the proper assessment of the previous year papers, you'll get a good wholesome package for your preparation, and you'll be able to perform to such a level that you'll be placed in any one of the institutes that I was referring in the previous. So if you are interested, please get back to us and you can Also contact us through this number and know more information regarding this. So first 2 marks question that we have started with is from the electricity chapter. So we have taken it in the same order of the chapters based on the blueprint. So all these questions are based on the blueprint and based on the order in the particular chapters also. So first question is mention the properties of electric charges. So the first property under this is additivity of charges. Very simple. If there are n number of charges, if you add that, you will get the total charges. Then conservation of charge. It is similar to that of conservation of energy. Charges cannot be destroyed or created. So the total number of charges will be always the same. And then quantization of charges, that is, charge is always an integral multiple of a fundamental unit of charge. So any order you can write this, but then all these 3 properties have to be mentioned. That is additivity, conservation and quantization. Just remember these 3 words: additivity, conservation and quantization, and you can easily write this answer. The second question is charges are additive in nature, explain. So just now previous slide I told you about the properties. So this is the first property that has been asked to explain. That is, the total charge of a system is equal to the algebraic sum of all the individual charges present in it. So just like I mentioned, if Q1, Q2, Q3 are the charges present in the system, etc., any number of charges, then the total charge is given by sum of these individual charges. So if you have 2 coulombs, 3 coulombs and 4 coulombs, if you want to find the total charge, just add it, 2 plus 3 plus 4. So that will be 9 coulombs. This is the very simple method of remembering this, but then we can always write the same definition, whatever is given over this. So this is about charges, additivity of charges in nature. Explain the quantization of charges. This is another property which was mentioned in the first question itself. You see, the electric charge on any body is always an integral multiple of the fundamental charge. And the expression that relates to this quantization is Q equals NE. Now, Q equals NE. What does the meaning of integral multiple means? Integral multiple of the fundamental charge. So, here the value of N will be either plus or minus 1, plus or minus 2, plus or minus 3, etc. like this. So, if it is positive charge, it will be plus. If it is negative charge, it will be minus. So, it will be either E or 2E or 3E, etc. like this, or minus E, minus 2E or minus 3, etc. like this. So, only this will be possible. Fractions or decimals will not be possible, like 1.2E, etc. is not possible. That is the meaning of this statement. It will be always an integral multiple of the fundamental charge E. State and explain Coulomb's law in electrostatics. So this can be rephrased and asked in another way. State Coulomb's law in electrostatics and write the Coulomb's law in vector form. So now when we people are writing the statement of this, the statement for both of them is same. The electrostatic force between 2 stationary point charges is directly proportional to the product of the magnitude of the 2 charges and inversely proportional to the square of the distance between the charges. So if you have 2 charges, Q1 and Q2, the force will be directly proportional to Q1 and to Q2. That is only the magnitude, of course. So this is about the product of the magnitude. Whether it is positive or negative charge, you should take only positive value because you are taking the modulus. And inversely proportional to the square of the distance between the charges. So inversely proportional to the square of distance between the charges. So now if we combine it and write it, we get an expression F equals to K Q1 Q2 by R square. In order to remove the proportionality, if you introduce the constant K and the value of K is 1 by 4 pi epsilon naught. And finally the expression for the force given by the Coulomb's law is this. If you want to write it in the vector form, just introduce a unit vector and this becomes R cube. So R vector, you can write it as R caps can be written as R vector by modulus of R. So that way you will be able to write it in this form of vector form also. Next, give any 2 properties of electric field lines. So they have asked only 2 properties, but we have listed all the properties because if it is asked in 3 marks, you can write 3 properties, or if they ask you to write any number of properties, 4 also you can write, that's why. So field lines start from positive charges and end at negative charges. So if you have positive and negative charges, field lines will start from positive and end at negative. That is the first point. In a charge-free region, electric field lines can be taken to be continuous curve without breaks. So the curves will be like this. It will not be like breaks with any breaks. It will be without any break. That it will be a continuous curves. 2 field lines can never cross each other. Means 2 field lines cannot cross each other. This is not possible because tangent for a particular curve at a point can be only 1. But if they intersect, it will be 2. So that is not possible. And also the direction also won't allow it to happen. Then electrostatic field lines do not form any closed loop. You know, in magnetic field we will have a closed loop like this, but in electric field line we will not have a closed loop. They will only be continuous curves. They will never form a loop. Then a tangent drawn to an electric field line at any point gives the direction of electric field at the point. So if this is the curve, if I take this point from here, if I draw a tangent, that will give the direction of the electric field at that point. The density of field lines is a measure of the strength of the electric field. Meaning is, if there are more number of electric field lines in a particular point and less number in another point, this point will have more strength than the other point. So that is the meaning of the 6th point. What? Density of field lines is a measure of the strength of electric field. So I repeat once again, they start from positive charges to negative charges. They are continuous curves. So you have to link like this and then read, that is continuous curves can never cross each other, then do not form any closed loops, then a tangent gives the direction, and then density gives the strength. So this is how you have to correlate the words and then remember it while reading. Find the force on a point charge 2 into 10 to the power of minus 6 coulomb, that is microcoulomb, placed at a point in a uniform electric field of 0.8 newtons per coulomb. So the formula for this is very simple, you know, that is force is equals to strength of the electric field times the charge that we have taken. So it says on a point charge, and then value of the charge is also given. Multiply these two, you will get the required answer. Very simple problem. You will be able to get answer less than a minute. So you can easily solve this. Now, state and explain Gauss law in electrostatics. The total electric flux passing through any closed surface is equal to 1 by epsilon naught times the net charge Q enclosed by the surface. So mathematically, if I write the flux denoted by phi E is equals to Q by epsilon naught. Q stands for the charge enclosed by the surface. So this is Gauss law, based on which you also have 5 marks questions that we will be seeing in another video. Now, coming to that of this chapter, that is the next chapter, electrostatic potential and capacitance. We have taken the most important questions from this. Now, once again, I remind you people, please subscribe to our channel to get a timely update of all the videos that we are going to upload. And this is examination time. Even 1 minute or 2 minutes of time will make a difference. So if you note early and if you start preparing in advance, it will always help you. And now getting back to the answer. See, generally potential means related to work done. So if it is for a point from infinity to the point, what is the difference here? A system of charges are there. So when a system of charges are there, we have to take that work done to assemble the system of charges. Generally, we will say moving, bringing, etc. But first we say assembling the system of charges by bringing charge from infinity to the respective positions. So this is by bringing each other from infinity to the respective positions. Meaning is, I want to create a system of 3 charges from points A, B and C. Now, whatever the total work is done in bringing one charge from there to here, from infinity to B and infinity to C, the work done is what we call it as electric potential energy of a system of charges. Then what happens to the potential energy of a system of 2 unlike charges when the distance between them is increased and they have given an assumption also no external electric field is there? In this case, potential energy increases. So if you look at the formula, you will understand why the potential energy increases. So R, if it decreases, the potential energy increases. So if it is increased, obviously the potential energy also increases in this case. So what is an equipotential surface? What will be the shape of equipotential surface corresponding to a single point charge? See, equipotential surface is any surface at which at each and every point the potential is same. So whatever the electric potential value you take at one point, it should be the same at all the points or each at every point on the surface. Now the next sub question is what will be the shape of equipotential surface corresponding to a single point charge? For a single point charge, the equipotential surface are concentric spherical surfaces center around the charge. So if you have a charge here, the equipotential surface for this charge will be a sphere. So this is how the equipotential surface will be aligned for a given charge. So it is in 2 dimensions, you will see it as a circle. Imagine in 3 dimensions, that is a sphere. So each and every point on the sphere, if you find, the potential will be same. That is why this is called as a equipotential surface. Mention any 2 factors on which the capacitance of parallel plate capacitor depends. So in this, first thing you remember this formula, C equals to epsilon A by D. Now once you know this formula, you can directly correlate A and D here. A is in the numerator, D is in the denominator. Numerator is directly proportional, denominator is inversely proportional. So first, area of the plate. Capacitance is directly proportional to the area of the plates. Larger the area, greater the capacitance. Then distance between the plates, inversely proportional. If you look at this, meaning is smaller the distance, greater the capacitance, and vice versa. So this formula you should not write, need not write in the answer, but if you remember the formula, you can easily answer this question. That's why I put the formula there. Now 2 capacitors, 3 microfarad and 6 microfarad are connected in series. Find the equivalent capacitance of the combination. So it is in series combination. Formula is given by 1 by C equivalent equals to 1 by C1 plus 1 by C2. So this is equals to that of 1 by C1 is 3 microfarad and C2 6 microfarad. Since both of them are in the same unit, I have not converted as 10 to the power of minus 6 or 10 power anything else, because both of them are same. If one is micro and other one is milli, you have to convert. If not, no need. So you know this is very simple. LCM is 6 over here. So this is 2 times, this is 1 time. So this becomes 3 by 6. So what does it implies? C equivalent will be equal to that of 6 by 3. That will be 2 microfarad. So that's very simple. You will take less than 20 seconds or 30 seconds to do this problem. Now what if this question is for parallel, if they ask? Very simple, put C equivalent is equal to that of C1 plus C2. So if all this here they ask it in parallel, you just change the formula a little bit. Now define drift velocity. This is for the 3rd chapter where we have started from here. Define drift velocity and mobility of free electrons in conductors. So drift velocity is when electrons in a conductor start moving under the influence of an electric field. So when the electric field is being applied and when the electrons start moving, that is what we call it as drift velocity. So it is the average velocity acquired by free electrons in a conductor when an external electric field is applied. Symbol is Vd, you need not write because they did not ask us to write the representation or symbol or denotation. Mobility. It is a drift velocity acquired per unit electric field. So again, this will be nothing but drift velocity per unit electric field. Again, they did not ask the expression, so you need not write it in the question and the answer for this question. But generally, if you know the expression, you can easily define it. Drift velocity per unit electric field. That's all. So name the 2 factors on which the resistance of a metallic wire depends. Now, for this, you just remember this expression. R is directly proportional to L by A. Now, numerator is directly, this is inversely proportional. So, resistance is directly proportional to the length and then inversely proportional to area of cross section. They asked only name the 2 factors. They did not ask us to write the relation. So, even if you write the name, length of the wire and area of cross section, it is good enough. But if you want, you can also add the information that it is directly proportional and this is inversely proportional. So list any 2 limitations of Ohm's law. Now you know Ohm's law, what the potential difference applied across the ends of a conductor is directly proportional to the current flowing through it, provided the physical conditions remain the same. So if it is limitation, then something which does not follow what the law states. So first thing is V ceases to be proportional to I. So generally what do we have? If V is directly proportional, we get a straight line. Suppose after some time, if it bends like this, which means they are not directly proportional, in that cases, Ohm's law will not be applicable. Then semiconductor diodes. You know, in semiconductor diodes, what happens? There is not only one particular type of a charges, we have both holes and electrons, N type, P type, whatever you have studied in semiconductor electronics, you know how they work and how they behave. Diodes do not obey Ohm's law. That is one of the reason for limitation. Then for some materials like gallium arsenide, the relation between V is not unique. When I say not unique, for the same value, we'll have different values of, for the same value of V, we'll have different values of I also. Or the vice versa also you can say. That is a dependency on V and I. So if it is not unique, then also this law will not be satisfied. And it is not applicable at very high and low temperatures. This is generally told, but you can skip this fourth point. You can only remember these 3 points, and accordingly you can write this answer. Graphically represent the variation of resistivity with absolute temperature for the following materials. So this is first for a copper. You see, for copper, it's a metal. For metals, when temperature increases, resistivity also increases. In a semiconductor, when the temperature increases, resistivity decreases. For nichrome, which is an alloy of nickel, chromium and iron, if you look at the graph, you will feel as if that it is increasing, but you see the value of resistivity 1.10 and 1.20, the difference is only 0.1. For a temperature variation of 0 to 800 Kelvin, the change in this is only 0.1 ohms centimeter. So this is almost steady for a large changes in temperature. So that is why it's a straight line, and the interpretation is like this. So these are the 3 graphical representations related to variation of resistivity with absolute temperature. Give any 2 differences between current and current density. Current density is a vector form that we derive for the current, which is a scalar. So that we will write down all the differences. So first to start with, we have, it is the rate of flow of charge through a conductor definition. It is the current flowing per unit cross-sectional area of a conductor. Second, we are just finding out whether it is a scalar or a vector. Current is a scalar, current density is a vector, because we purposely take that accordingly. Third one is SI unit is ampere. Here the SI unit is ampere per square meter. So it is ampere per meter square also can rate. Formula I equals to Q by T, and here formula J equals to I by A. So any 2 differences you can write. I would suggest you people to write the definition and scalar or the unit, which is more easy to remember and also to write. But you can write any 2 among these 4 points for fetching 2 marks from this question. State Kirchhoff's rules of electrical network. There are 2 rules, junction rule and loop rule. So what does junction rule says? In an electrical network, at any junction, the sum of the currents entering the junction is equal to the sum of currents leaving the junction. So if you have a junction, if you have number of currents entering and leaving, let us say this is I1. So here the currents that are entering the junction is I1, I2 and I3. The one leaving is I4. So sum of all the currents that are entering is I1 plus I2 plus I3, and the one leaving is I4. And then in the loop rule, if you see, it says the algebraic sum of changes in potential around any closed loop involving resistors and cells is equals to 0. So summation of delta V is equals to 0. V is given by I into R. So written it directly in this. So 18th one, draw the Wheatstone Bridge circuit and write the condition for its balance. So this is the diagram of the Wheatstone Bridge. So this diagram you can easily draw by using the concept of symmetry. So if you just know about the symmetry, you can draw this diagram easily. So these arrow marks are not necessary. So that shows only a balanced condition. It's not necessary. You can draw without that also. Now here you have to take 4 resistors. So draw a rhombus, and then each of a side you insert a resistor and then connect it to a cell, and a galvanometer, and like a diagonal you have to remember, and the balance condition is R1 by R2 is equals to R3 by R4. So here you can write R2 by R1, I have written. You can also write R1 by R2 and R3 by R4. So however you write, it won't make a difference. But don't interchange and write R2 by R1, R3 by R4 will not be correct. So this is correct, even this is also correct. So this is about the diagram of Wheatstone Bridge circuit and the condition for balance. Write the expression for Lorentz force. See, the moment you remember or hear the word Lorentz, remember two things. One is electric field, another one is magnetic fields. See, if you take a charge and place it in electric field, it will experience electric force. If you keep it in magnetic field, it will experience magnetic force. The combination of these two is Lorentz force. Very easy to remember. What it says, the total force on a moving charge in the presence of both electric field and magnetic field is called as the Lorentz force. Now the expression is F vector is equals to that of Q times E vector plus V vector cross B vector. So each of them are given. What are they? Q is the charge, E is the electric field, B is the magnetic field, and V is the velocity of the charge. Then when the force experienced by moving charge and magnetic field becomes maximum and minimum. So this becomes maximum and minimum when the direction or the angle between the velocity and the magnetic field is 90 degrees. So sin theta is 1 when theta equals to 90 degrees. So the angle between the velocity of the moving charge and the magnetic field is 90 degrees. It will be a maximum force. Then if the angle is 0 degrees or it is 180 degrees, then we get sin as 0. That will be minimum. So the minimum force is this and maximum force is that. The value of the force will not be 1. Don't get confused. Sin theta will be 1 and sin theta will be 0. So for this we say it as two things. One is parallel and the other one is anti-parallel. So anti-parallel is when E and this velocity and B are in opposite direction. So this is anti-parallel and this is parallel. So these are the two scenarios. So like I said, you have seen 20 questions almost now, 2 marks questions. So if you people thoroughly prepare all the questions that we have crafted by looking at the previous year question papers and the model papers and the preparatory papers, and also even some of the previous year papers in which they have been repeated most frequently, we have collected that. So if you people go through them, you will be able to answer this 2 marks question very easily. So if you want to get a timely update of all the videos that will be uploading for 3 marks and 5 marks in the coming days, today and tomorrow, subscribe to our channel so that you will be getting an early access. The more early you get, more time you get for preparing. Now the next question. When does a current carrying conductor placed in a uniform magnetic field experience maximum and minimum force? Some of you may think, just now we saw this question. No, there is a small change in this. There it was only a moving charge. Here it is a carrying conductor itself. So in a conductor, lot of charges will be flowing. When I say a single charge, only a single charge. So that way it is different. Now, when it will be maximum and minimum? The force will be maximum when perpendicular. What are the things perpendicular to the conductor and the field? Now the field can be either into the plane or out of the plane. So out of the plane or into the plane, doesn't matter. Perpendicular values we can see with the formulas and everything. It should be like this. Or you can say the length of the conductor is perpendicular to the field, or the current flowing also, because current will flow along the conductor only. So the direction between that also you can say. But since it is as based on conductor, it is best to write the conductor. So when it is perpendicular, it is maximum. When it is parallel, it is minimum. So 0, that will be the minimum value. Whenever we write the expression, we will get to know. So discuss any 2 cases in which the magnetic force on a charged particle in a magnetic field is 0. In this, already this is a known condition, because when we were discussing about maximum and minimum, we saw this. If it is parallel or anti-parallel to that of the magnetic field, that is velocity we get minimum force, that is 0. And in the formula we have V cross B. V vector is velocity vector. You know, whenever the particle is at rest, any object which is at rest, the velocity will be 0. So if it is 0, then the magnetic force will be also 0. Remember, this is not maximum minimum. Here, both the cases it is minimum, that is 0 itself. But one case is where the charged particle is at rest. Another case is when they are in parallel condition or an anti-parallel condition. Next, mention any two factors on which current sensitivity of a galvanometer depends. So this is already known to many of you people because it is in the practicals also. Some of you might have got this experiment to perform during the practical exam also. So here, without wasting much time, let us see what are they. Number of turns in the coil N, area of the coil A, magnetic field whatever is applied, that is B, and the torsional constant. So whatever restoring couple is being given over there for the spring, the torsional constant is there, K. So it is also depending on this. Any two of this factor you write, you will get 2 marks, 1 mark for each of the factor. So it is up to you people to choose. Don't write only the symbol, write the full form of this. Then state Lenz law, what is its significance? See, Lenz law, the moment you hear this word Lenz law, opposing, you should remember, that's all. So the ones to correlate are, I always suggest that Lenz and opposing. What does it oppose? Lenz law is related to what? Electromagnetic induction. So what is changing in that? Magnetic flux. So what can be opposing that? Induced current, that's it. So the polarity of the induced EMF is such that it tends to produce a current which opposes the change in magnetic flux. You know, if this is not satisfied, then it will be disproving law of conservation of energy. Therefore, we will be able to argue all those things in 5 marks question. Now we don't need that, so I will stop with that. Now, significance. What is the significance of Lenz law? It gives a polarity of the induced EMF. So whatever induced EMF is generated, the polarity of that induced EMF will be given by the Lenz law. So this is state Faraday's law and Lenz law of electromagnetic induction. Lenz law I have not mentioned here. Why have I not mentioned Lenz law? Because in the previous slide only we were discussing about that. That is the reason why I have not mentioned about Lenz law. So when Lenz law is already discussed, only Faraday's law we shall discuss. So this Faraday's law states that whenever there is change in magnetic flux linked with the closed circuit, an EMF is induced in the circuit. So whenever there is magnetic flux linked with the coil changes, then an induced EMF will be produced in the circuit. Let us say we have a coil, a magnet is brought in and out of this, or the coil is moved in and out of that, or both of them are moved. In all the cases, it will vary, flux will change. Whenever flux changes, induced EMF will be there. And then this magnitude of the induced EMF will be equal to the rate of change of magnetic flux. That is, EMF is equals to rate of change. You know, d phi by dt is basically differentiation, which tells about the changes. So the rate of change, because time is involved in it. So that is how you have to write Faraday's law. After this, you should write Lenz law. 1 mark for Faraday's law and 1 mark for Lenz law will be there. Now Lenz law I have not written here, already told you it is in the previous slide. Write an expression for induced EMF in a straight conductor moving perpendicular to uniform magnetic field and explain the terms. So in the question itself, perpendicular is mentioned. So when perpendicular is mentioned, angle is 90 degrees. If not, we have to write about sin theta also there. Since it is given perpendicular, sin 90 is 1, we will not write about that. The expression for this is given by epsilon is equals to that of BLV, where epsilon is the induced EMF in volts, B is the magnetic field strength in Tesla, L is the length of the conductor which is placed in the magnetic field, and V is the velocity of the conductor. Remember, the conductor itself is moving because they say straight conductor moving. So the movement will be resulting in velocity. So the velocity of the conductor which is expressed in meters per second. Write the principle of AC generator, mention the expression for induced EMF in it. So this is about AC generator, and they are asking us to mention the expression for induced EMF in it also. First of all, generator. What do we get from a generator? Current. So current, generally we don't say induced current, it is or induced EMF or an alternating EMF or induced EMF. Whatever you say, accordingly it will be fine. So first of all, what is the principle it works? Electromagnetic induction. So for this also you can remember an acronym EMI, not the one which you people pay every month. This is different. Electromagnetic induction. And what is this phenomenon? Since they asked us to write it, not name it. If they ask you to name the principle, you write only electromagnetic induction. But they have asked to write it. So when a coil is rotated in a uniform magnetic field, the magnetic flux linked to the coil changes continuously, and hence an alternating EMF is induced in the coil. So let us say we have a magnetic field generated by two different magnets. They are not the same magnet broken and placed, two different magnets, and we have a coil that is being used in this, right? So of course slip rings and all diagram will be there, carbon brushes, everything that you people already know. So when we rotate this coil, flux will change. Why the flux will change? The coil will be like this, will become parallel to this. The coil will be parallel like this, then will become perpendicular to the field again like this. So when we rotate, the flux changes. When the flux changes, obviously an alternating EMF will be involved in this. So this is about the principle of electromagnetic induction. So when I say electromagnetic induction, you have to remember this accordingly and write it. Now the next sub question, mention the expression for induced EMF. So induced EMF is given by NBA omega sin omega t. They have not asked us to explain the terms involved in this, so we have not written. If you want to write, you can write the number of turns involved, magnetic field, area of the coil, rotational velocity, that is angular velocity, and then sine of the phase angle that is being used for this generation. Then the other way of rephrasing this question is, give the principle of AC generator. Why is a current induced in AC generator called as alternating current? Principle is the same. You need not write the expression for this question. You need to only write this much. The direction of current changes periodically. That is every half cycle. So for every half cycle, the current changes its direction. Positive, negative, positive, negative, positive to negative. So that is why it is called as an alternating current. You know, if it is not changing, then it is called as a direct current. Draw a neat diagram of a simple AC generator and label the parts. So this is a very easy diagram. Magnets are not mentioned, I just mentioned it. If you people want to mention it, you can mention. If not, also you can leave, because in the textbook also it is the same. So this is a coil, rectangular coil, axle on which it is mounted. So basically the axle only will be connected to a petrol or gasoline engine or any of this rotating mechanism. Mechanically even can be connected to a flowing water, etc. like this, or any steam also, turbine, anything of that sort. That way it has to be rotated. These two are the slip rings which establish a connection between the coil and the outside voltage which it has to be derived. So it will be derived across the load resistance that you people have seen earlier in different scenarios. So we will have a setup of that. And then this is these two are the carbon brushes. So just draw the diagram neatly, and then you should not draw artistic diagram. So don't keep drawing the coil like this. So like this and all, you should not draw the coil. You should draw a single line only. Artistic diagrams are not accepted in science, that's why. What is an AC generator? Why the current induced in it called as alternating current? Answer for the second half already we have done, but still I have given the answer here. But then first half, what is an AC generator? We saw what is the principle of an AC generator. So don't get confused between the principle. Principle is the law or any kind of statement which rules or which governs the working of a device. Here they are asking what is the device? Both are not same. So AC generator is a device that converts mechanical energy into electrical energy. So where is the mechanical energy? Mechanical energy is by rotating. Electrical energy is by generation due to that of electromagnetic induction. So that is a generator. It's a device or it's a machine. Also we can say, give any two uses of microwaves. This is EM waves. Mention any two applications of microwaves. See, these are all theoretical questions. There is no numerical problems. There is no much reasoning. It's only fact. You learn this, you can write the answer. So they're used in radar system, used in aircraft navigation. You might have seen in movies, jet planes when they're moving around, they will have to navigate terrains which they cannot see because the speed will be 2500, 3000 kilometers per hour. So they will have a radar system which will guide them for navigation, and radar systems are also used in detection also. If any foreign or any unknown aircraft enter, that also can be detected by using a radar. Then they are used in speed guns. There will be interceptor vehicles, even might have seen in some of them, you might have seen it on the road. These guns will be finding out at what speed the cars are moving. So in that also they use it. And also they are used in microwave ovens. Ovens are used in many households. In those households, if you see, that is another use of microwave. Either any two application or any two uses. If they ask, you have to write the same. If they ask for 3 marks, you write all the 3. Mention any two uses of infrared radiation or give any two uses of infrared radiation. So night vision devices. So usually these are all night goggles, like what people use for night vision. Infrared will be used in that. And it can reflect even in the dark and then reach back. That is why infrared is being used, which have wavelength more than that of red. So they are used to see objects in darkness. You might have seen some people during this, shows in which they'll go to supernatural places and then detect some kind of energy or negative energy. They'll use these kind of goggles. In warfare, when soldiers move in dark to attack an enemy or something like that, they'll use this night vision devices. TV and remote controls. So all the remotes that you people use at home for television and for VCR player or DVD player or a mount system, mic systems nowadays, even for fans also we have remotes. All the remotes, almost majority of the remotes work with IR, a signal transmission only. So that is another use. Then mention any two applications of UV, give two applications of UV rays, write any two uses of ultraviolet radiation. This has been asked in 3 papers, previous papers, model paper, preparatory. In many cases they have asked this. So we have given 3. So you can write any two of this. It is used in water purifiers to kill the germs in water. All the water that is being filtered in the RO, or you say water filter at home, right? Purifiers, there will be UV lamp. The water will flow through this and they will be exposed to UV lamp that will kill all this. Sterilization of medical instruments. If you see, in few cases they'll use hot water to sterilize few medical equipments, but that is not so safe because not all the germs will be killed in it. But we will use a UV. This UV has the ability to kill, even just like even the sunlight which is not filtered by ozone will send UV. So if we expose it to that also, it will kill, but it is very dangerous for all other living beings. So sterilization of medical instruments. Then detection of forged currency and documents. If you have visited a bank, the teller, the cashier, anybody would have seen while counting, if they feel like it is a counterfeit, fake currency, quota note antaralla, adidre, they'll keep it below a UV lamp. Adral noಡಿದಾಗ all the embedded ink irutte ಒಳಗಡೆ ಮತ್ತೆ ಅದು ಕೆಲವೊಂದು symbols irutte. If at all visible, it is original. ಇಲ್ಲ ಅಂತಂದ್ರೆ ಅದು fake currency ಅಂತ it will be decided. So it will create fluorescence. ಆ ಫ್ಲೂರೆಸೆನ್ಸ್ ಇಂದ ಅದನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡ್ಬೋದು. ನೀವು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಬೇಡ, ಏನು ಯೂಸ್ ಅಂತ ಬರೆದ್ರೆ ಸಾಕು. ನೆಕ್ಸ್ಟ್, ನೇಮ್ ದ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ಸ್ ಯೂಸ್ಡ್ ಫಾರ್ ದ ಫಾಲೋಯಿಂಗ್ ಅಪ್ಲಿಕೇಶನ್. ರೇಡಾರ್ ಸಿಸ್ಟಮ್ ಯೂಸ್ಡ್ ಇನ್ ಏರ್ಕ್ರಾಫ್ಟ್ ನೇವಿಗೇಷನ್, ಅದಕ್ಕೆ ಮೈಕ್ರೋವೇವ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ರಿಮೋಟ್ ಸ್ವಿಚಸಲ್ಲಿ ಇನ್ಫ್ರಾರೆಡ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆಲ್ರೆಡಿ ನೋಡಿರೋದೆ, ಇದು ಜಸ್ಟ್ ಅನ್ ಅಪ್ಲಿಕೇಶನ್ ಇನ್ ಅ ಡಿಫ್ರೆಂಟ್ ವೇ. ರೈಟ್ ಎನಿ ಟು ಯೂಸಸ್ ಆಫ್ ಎಕ್ಸ್ರೇಸ್. ಎಕ್ಸ್ರೇಸ್ ಅನ್ನೋದು ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ. ಯಾವಾಗ ಯಾರು ಬಿದ್ದು ಏಟಾಗಿ ಬೋನ್ ಏನಾದ್ರು ಫ್ರ್ಯಾಕ್ಚರ್ ಆದರೆ ಅದನ್ನು ನೋಡೋದಕ್ಕೆ ಎಕ್ಸ್ರೇನೇ ಕೊಡ್ತಾರೆ. ಸೊ ಮೋಸ್ಟ್ ಆಫ್ ಯು ಮೈಟ್ ಬಿ ನೋಯಿಂಗ್. ಸೊ ಮೆಡಿಕಲ್ ಡಯಾಗ್ನೋಸಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದ ಯೂಸ್. ಅಲ್ಲಿ ಬೋನ್ ಫ್ರ್ಯಾಕ್ಚರ್ಸು ಮತ್ತು ಡೆಂಟಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ವಿ ವಿಲ್ ಯೂಸ್ ಎಕ್ಸ್ರೇ. ಸೆಕ್ಯೂರಿಟಿ ಸ್ಕ್ಯಾನಿಂಗ್, ಏರ್ಪೋರ್ಟಲ್ಲಿ ನೋಡಿದ್ರೆ ದೆರ್ ವಿಲ್ ಬಿ ಅ ಬೆಲ್ಟ್, ಕನ್ವೇಯರ್ ಬೆಲ್ಟ್, ಅದ್ರ ಮೇಲೆ ಎಲ್ಲ ಇಡ್ತಾರೆ. ಅದೊಂದು ಸ್ಮಾಲ್ ಚಾಂಬರ್ ಒಳಗಡೆ ಹೋಗಿ ಹೊರಡೆ ಬರುತ್ತಲ್ಲ, ಅದು ನಥಿಂಗ್ ಬಟ್ ಎಕ್ಸ್ರೇ. ಒಳಗಡೆ ಏನಿದೆ ಅನ್ನೋದನ್ನ ದೇ ವಿಲ್ ಬಿ ಏಬಲ್ ಟು ಐಡೆಂಟಿಫೈ. ಇಟ್ ಈಸ್ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಸೇಫ್ಟಿ ಪರ್ಪಸ್, ಅದಕ್ಕೋಸ್ಕರ ಮಾಡ್ತಾರೆ. ಆಮೇಲೆ ಟ್ರೀಟ್ಮೆಂಟ್ ಆಫ್ ಸರ್ಟನ್ ಫಾರ್ಮ್ಸ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್, ನಾಟ್ ಆಲ್ ಫಾರ್ಮ್ಸ್, ಸರ್ಟನ್ ಫಾರ್ಮ್ಸ್ ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಆಮೇಲೆ ಕ್ರಿಸ್ಟಲೋಗ್ರಫಿ ಇಸ್ ಸ್ಟಡಿ ಅಬೌಟ್ ಕ್ರಿಸ್ಟಲ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್, ಅದರಲ್ಲೂ ಎಕ್ಸ್ರೇನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಇದರಲ್ಲಿ ನೀವೇನಾದ್ರು 2 ಬರೀಬೋದು. ಐ ವುಡ್ ಸಜೆಸ್ಟ್ ದ ಫಸ್ಟ್ 2 ವಿಲ್ ಬಿ ಈಸಿ ಫಾರ್ ಯು ಟು ರೈಟ್ ಆಲ್ಸೋ and to remember also. Next we come to atoms. So write 2 limitations of Bohr's atom model. So first, it is applicable only to hydrogen like atoms. Even helium could explain madakagala because it is not similar to hydrogen. So that is where it fails to express about the spectra of multi-electron atom. ಒಂದೇ ಒಂದು electron ಮಾತ್ರ it is applicable. And it was also not able to explain the fine structure and splitting of spectral lines. ಇದನ್ನ ಬೇರೆ ರೀತಿ ಹೇಳ್ಬೋದು, ಅಂದರೆ ಸ್ಪೆಕ್ಟ್ರಲ್ ಲೈನ್ಸ್ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋಕ್ಕೂ ಆಗಿಲ್ಲ ಅಂತನಾದ್ರು ಬರಿಬೋದು. ದೀಸ್ ಆರ್ ಸ್ಪೆಸಿಫಿಕ್ ಟರ್ಮ್ಸ್. ಝೀಮನ್ ಎಫೆಕ್ಟ್ ಅಂಡ್ ಸ್ಟಾರ್ಕ್ ಎಫೆಕ್ಟ್ ಅನ್ನೋದು ಸ್ಪೆಸಿಫಿಕ್ ಟರ್ಮ್ಸ್. ಯು ಜಸ್ಟ್ ರೈಟ್ ದಿಸ್ 2 points. It's more than enough for you to write the limitations of Bohr's atomic model. One of the most convenient and the most recent one, but then still it has some drawback. Limitations of Rutherford's atomic model. So ಒಬ್ಬೊಬ್ರದ್ದು ಅಟಾಮಿಕ್ ಮಾಡೆಲ್ ಬಗ್ಗೆ ನೀವು ಯೋಚನೆ ಮಾಡಿದಾಗ ರೂದರ್ಫೋರ್ಡ್ ಮಾಡೆಲಲ್ಲಿ ಏನು ಲಿಮಿಟೇಷನ್ಸ್, ವಾಟ್ ಇಸ್ ದ ಡಿಸ್ಅಡ್ವಾಂಟೇಜ್ ಅಥವಾ ಲಿಮಿಟೇಷನ್ಸ್ ಅನ್ನೋದು ಈ 2 ಪಾಯಿಂಟ್ಸಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಬೋದು. ಇಟ್ ಕುಡ್ ನಾಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ದ ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ ಅನ್ ಆಟಮ್. ಏನು ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ ಅನ್ ಆಟಮ್ ದೆ ಟೋಲ್ಡ್, ರೂದರ್ಫೋರ್ಡ್ ಕರೆಕ್ಟಾಗಿ ಹೇಳಿದ್ರು, ಅದಕ್ಕೆ ಅದನ್ನು ನ್ಯೂಕ್ಲಿಯರ್ ಮಾಡಲ್ ಅಂತಲೇ ಹೇಳ್ತಾರೆ. ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ರಿವಾಲ್ವ್ ಆಗುತ್ತೆ ಅಂತ. ಹಿಂಗೆ ಮಾಡಬೇಕಾದ್ರೆ ಇಟ್ ವಿಲ್ ರೇಡಿಯೇಟ್ ಎನರ್ಜಿ. ವೆನ್ ಇಟ್ ರೇಡಿಯೇಟ್ಸ್ ಎನರ್ಜಿ ಅದು ಸ್ಪೈರಲ್ ಆಗಿ ಲಾಸ್ಟ್ಗೆ ನ್ಯೂಕ್ಲಿಯಸಲ್ಲಿ ಬಿದ್ದೋಗುತ್ತೆ. ಸೊ ದೇ ಆರ್ ಬೋತ್ ಆಪೋಸಿಟ್ ಚಾರ್ಜಸ್. ಇಟ್ ವಿಲ್ ರಿಸಲ್ಟ್ ಇನ್ ಆ್ಯನಿಹಿಲೇಷನ್. ಆ್ಯನಿಹಿಲೇಷನ್ ದ ಕಂಪ್ಲೀಟ್ ಡೆಸ್ಟ್ರಕ್ಷನ್. ಆ ಥರ ಕಂಪ್ಲೀಟ್ ಡೆಸ್ಟ್ರಕ್ಷನ್ ಆದರೆ ಆಟಮ್ ಶುಡ್ ಬಿ ಹೈಲಿ ಅನ್ಸ್ಟೇಬಲ್. ಬಟ್ ರಿಯಾಲಿಟಿಯಲ್ಲಿ ಅನ್ಸ್ಟೇಬಲ್ ಆಗಿದ್ದಿದ್ರೆ ಯು ಆ್ಯಂಡ್ ಮೀ ವೋಂಟ್ ಎಕ್ಸಿಸ್ಟ್. ಈ ಪ್ರಪಂಚನೇ ಇರ್ತಿರಲಿಲ್ಲ. ಬಟ್ ವಿ ಆರ್ ಲಿವಿಂಗ್ ಆ್ಯಂಡ್ ದ ವರ್ಲ್ಡ್ ಎಕ್ಸಿಸ್ಟ್. ಅಂದರೆ ಆಟಮ್ಸ್ ಆರ್ ಸ್ಟೇಬಲ್ ಅಂತ. ಸೊ ದಟ್ ಈಸ್ ದ ಫಸ್ಟ್ ಡ್ರಾಬ್ಯಾಕ್ ಆರ್ ಲಿಮಿಟೇಷನ್ ಆಫ್ ರೂದರ್ಫೋರ್ಡ್. ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ರಿವಾಲ್ವಿಂಗ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಶುಡ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ರೇಡಿಯೇಟ್ ಎನರ್ಜಿ. ರೇಡಿಯೇಟ್ ಎನರ್ಜಿ ಅಂದರೆ ಎನರ್ಜಿ ಲೂಸ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ಲೂಸ್ ಮಾಡ್ತಾ ಹೋದರೆ ಅದು ಸರ್ಕ್ಯುಲರ್ ಪಾತಲ್ಲಿ ಇರೋಕ್ಕಾಗಲ್ಲ. ಎನರ್ಜಿ ಕಮ್ಮಿ ಆಗ್ತಿದ್ದಂಗೆ ಅದು ಸ್ಪೈರಲ್ ಪಾತಿಗೆ ಬರುತ್ತೆ, ರೇಡಿಯಸ್ ಕಮ್ಮಿ ಆಗ್ತಾ ಬರುತ್ತೆ. ಲಾಸ್ಟಲ್ಲಿ ಅಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯಸಲ್ಲಿ ಬೀಳುತ್ತೆ, ಕೊಲಾಪ್ಸ್ ಆಗುತ್ತೆ. ಬಟ್ ಅದು ಆಗಲ್ಲ. ದಟ್ ಈಸ್ ದ ಲಿಮಿಟೇಷನ್. And atomic spectra ಬಗ್ಗೆ they could not explain. It could not explain the discrete line spectra of hydrogen and other atoms. So line spectra, how as per Rutherford suggestion ಏನಿತ್ತು continuous spectrum ಅಂತ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಿದ್ರು. ಬಟ್ ಇಟ್ಸ್ ನಾಟ್ ದ್ಯಾಟ್. Experiments and other spectral analysis, spectroscopy-ನಲ್ಲಿ we have identified this. It's a discrete line spectra which was not told properly by them. How does the total energy of an electron revolving in nth orbit of hydrogen atom depend on the principal quantum number of the orbit? What is the significance of the negative sign in the expression for total energy of electron in a nitrogen atom? See, ಈ ಫಾರ್ಮುಲಾ ನೀವು ಬೈ ಹಾರ್ಟ್ ಮಾಡಿದ್ರೆ 2 marks ಪ್ರಾಬ್ಲಮ್ಸ್ ಏನಾದ್ರು ಕೇಳಿದ್ರು ನೀವು ಮಾಡ್ಬೋದು. ಈ ಥರ ಥಿಯರಿಟಿಕಲ್ ಕ್ವಶನ್ ಕೇಳಿದಾಗಲೂ ಆನ್ಸರ್ ಮಾಡ್ಬೋದು. ಸೊ En ಈಸ್ ಈಕ್ವಲ್ ಸೆಟ್ ಆಫ್ -13.6 by n square eV. ಸೊ ಇದನ್ನು ಆಲ್ರೆಡಿ ಡಿರೈವೇಷನ್ಸ್ ಎಲ್ಲ ಇದೆ. ಇಲ್ಲಿ ವಿ ವಿಲ್ ನಾಟ್ ಬಿ ಡಿಸ್ಕಸಿಂಗ್ ಅಬೌಟ್ ದ್ಯಾಟ್. ಹಂಗಾದರೆ the total energy is proportional to -1 by n square. So this is what you are supposed to write, but idin bardre it will be easy to write this and correlate. What is the negative sign? Negative sign indicates that electron is bound to the nucleus. So ತುಂಬಾ ಜನ ಕೇಳ್ತಾರೆ ನೆಗೆಟಿವ್ ಮತ್ತು ಬೌಂಡಿಂಗ್ ಹೆಂಗೆ, ಯಾವಾಗಲೂ ಪಾಸಿಟಿವ್ ಇದ್ರೇನೆ ಈ ಥರ ಬೌಂಡಿಂಗ್ ಇದೆಲ್ಲ ಆಗೋದು. ನೆಗೆಟಿವ್ ಪಾಸಿಟಿವ್ ಎನರ್ಜಿ ಇದ್ದರೆ ಈವನ್ ವಿತೌಟ್ ಸಪ್ಲೈಯಿಂಗ್ ಎನಿ ಎಕ್ಸೈಟೇಷನ್ ಎನರ್ಜಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಜಸ್ಟ್ ಜಂಪ್ ಔಟ್ ಆಫ್ ದೇರ್ ಶೆಲ್ಸ್. ಆರ್ಬಿಟ್ಸಿಂದ ಹೊರಡೆ ಹೋಗುತ್ತೆ. ಈವನ್ +1 ಗ್ರಾವಿಟೇಷನ್ ಚಾಪ್ಟರಲ್ಲಿ ಎನರ್ಜಿ ಆಫ್ ಅ ಸ್ಯಾಟಲೈಟ್ ನ್ಯಾಚುರಲ್ ಆರ್ಟಿಫಿಷಿಯಲ್ ಮಾಡಿದಾಗಲೂ -n ಇಂಡಿಕೇಟ್ ಆಗುತ್ತೆ. ಆ -ಇಂದ ವಾಟ್ ಕ್ಯಾನ್ ವಿ ಸೇ? ಇಟ್ ಈಸ್ ಬೌಂಡ್. ಅದು ಮೈನಸ್ ಇರೋದು 0 ಆದರೆ ಲಿಟಲ್ ಬಿಟ್ ಸಪ್ಲೈ ಮಾಡಿದ್ರೆ ಆಟೋಮೆಟಿಕ್ಕಾಗಿ ಹೋಗ್ಬಿಡುತ್ತೆ. ಪಾಸಿಟಿವ್ ಆಗಿಬಿಟ್ರೆ ಈವನ್ ವಿತೌಟ್ ಎನಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಎನರ್ಜಿ ಇಟ್ ವಿಲ್ ಮೂವ್ ಔಟ್. ಸೊ ದಟ್ ಈಸ್ ವೈ ದ ನೆಗೆಟಿವ್ ಸೈನ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನೆಗೆಟಿವ್ ಸೈನ್ ಇದ್ದರೆ ಏನಾಗುತ್ತೆ, ಅಷ್ಟು ಎನರ್ಜಿನ ಓವರ್ಕಮ್ ಮಾಡಿದ ಮೇಲೆ ದೇ ವಿಲ್ ಬಿ ಏಬಲ್ ಟು ರಿಮೂವ್. So that is what ionization potential and ionization energy ಅಂತ ಏನು ಹೇಳ್ತೀವಿ. ವೆನ್ ವಿ ಸಪ್ಲೈ ಎಕ್ಸ್ಟರ್ನಲ್ ಎನರ್ಜಿ ಅದನ್ನ ರಿಲೀವ್ ಮಾಡ್ತೀವಿ. ಸೊ ಅದು ನೆಗೆಟಿವ್ ಆಗಿಲ್ಲ ಅಂತಂದರೆ ಅದು ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ, ವಿಚ್ ಇಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ದಟ್ ಈಸ್ ವೈ ದಿಸ್ ಬೌಂಡ್ ಟು ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಅಸ್ ಟು ನೋ. ಡಿಸ್ಟಿಂಗ್ವಿಶ್ ಬಿಟ್ವೀನ್ ಕಂಡಕ್ಟರ್ಸ್ ಅಂಡ್ ಇನ್ಸುಲೇಟರ್ಸ್ 6th ಕ್ಲಾಸಿಂದ ಓದ್ತಾ ಇದ್ದೀವಿ ಸರ್. ಕಂಡಕ್ಟರ್ಸ್ ಅಂಡ್ ಇನ್ಸುಲೇಟರ್ಸ್ ಅಂದರೆ ಇಟ್ ವಿಲ್ ಕಂಡಕ್ಟ್ ಕರೆಂಟ್, ಇದು ವಿಲ್ ನಾಟ್ ಕಂಡಕ್ಟ್ ಕರೆಂಟ್ ಅಂತ ಅನ್ಕೋಬೋದು. ಬಟ್ ಅದನ್ನು ಬರೆಯೋಕ್ಕಾಗಲ್ಲ. ವೈ? ಬಿಕಾಸ್ ಬೇಸಿಸ್ ಆಫ್ ಬ್ಯಾಂಡ್ ಥಿಯರಿ. ನೀವು ಅದನ್ನು ಬರೆದ್ಬಿಟ್ಟು ನಾನು ಕರೆಕ್ಟಾಗಿ ಬರ್ದಿದ್ದೀನಿ ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ಯು ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಮಾರ್ಕ್ಸ್ ಇವನ್ ದಟ್ ಇಸ್ ಕರೆಕ್ಟ್. ಕಾನ್ಸೆಪ್ಟ್ ವೈಸ್ ಅದು ತಪ್ಪಲ್ಲ, ಕರೆಕ್ಟೇ. ಬಟ್ ವಿ ಕೆನಾಟ್ ರೈಟ್ ದಟ್ ಬಿಕಾಸ್ ಬೇಸಿಸ್ ಆಫ್ ಬ್ಯಾಂಡ್ ಥಿಯರಿ. ಸೊ ಹಿಯರ್ there will be no energy gap or very less energy gap between the valence and the conduction band. ಆಯಿತಾ? ಸೊ ಒಂದು ವೆರಿ ಲೆಸ್ ಗ್ಯಾಪ್ ಇರುತ್ತೆ ವ್ಯಾಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಆ್ಯಂಡ್ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್ಗೆ, ಅಥವಾ ಓವರ್ಲ್ಯಾಪ್ ಆಗಿರುತ್ತೆ ಎರಡುವೆ. ಸೊ ಹಾಗಾಗಿ ದಿಸ್ ಇಸ್ ಹೌ ಯು ಹ್ಯಾವ್ ಟು ಡಿಫೈನ್ ಎ ಕಂಡಕ್ಟರ್. ಇನ್ಸುಲೇಟರ್ಸಲ್ಲಿ ವೆರಿ ಲಾರ್ಜ್ ಗ್ಯಾಪ್ ಇರುತ್ತೆ ಬಿಟ್ವೀನ್ ದಿಸ್ ವ್ಯಾಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಆ್ಯಂಡ್ ದ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್. ಆವಾಗ ಇಷ್ಟೇ ಇದ್ದರೆ ಫಾರ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಟು ಮೂವ್ ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಈಸಿ. So if there are electrons, they can easily jump here. ಇಲ್ಲಿ already some of them will be there, right? Overlapping ಆಗಿದ್ರೆ. But ಇಲ್ಲಿ ಇಷ್ಟೊಂದು ಫಾರ್ಬಿಡಿನ್ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಇರೋದನ್ನ ಜಂಪ್ ಮಾಡಲಿಕ್ಕೆ ಲಾಟ್ ಆಫ್ ಎನರ್ಜಿ ಬೇಕು. ಸೊ ಅದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ನಾಟ್ ಬಿ ಫ್ರೀಲಿ ಅವೈಲಬಲ್ ಆಸ್ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಇನ್ಸುಲೇಟರ್ಸಲ್ಲಿ ಕಂಡಕ್ಟ್ ಆಗಲ್ಲ, ಕಂಡಕ್ಟರ್ಸಲ್ಲಿ ಫ್ರೀಲಿ ಅವೈಲಬಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫ್ರೀ ರೆಡಿ ಆಗಿರುತ್ತೆ. ಸೊ ಇಟ್ ಇಸ್ ಈಸಿ. Then electrons can easily move to conduction band, cannot easily jump to conduction band. So that is related to distinguishing between them. You can write an example also. Ella metals anta baribodu. You can also write, but I would suggest these 2 points. Inno illa na innond point beku anta if you feel like, you can write examples. You can write all metals related to this. Illi you can write all any kind of insulators, rubber, plastic, etc. You can write. Distinguish between intrinsic and this is semiconductor chapter, intrinsic and extrinsic semiconductors. ನೋಡಿ ಆಗಲೇ ವಿ ಆರ್ ಇಂಟು ದ 40th ಕ್ವೆಶ್ಚನ್. ಸೊ 40 ಕ್ವೆಶ್ಚನ್ಸ್ ನಿಮಗೋಸ್ಕರ ನಾವು ಅನಲೈಸ್ ಮಾಡಿ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀವಿ. ಯಾಕೆ ಅಂತಂದರೆ ಯು ನಾಟ್ ಹ್ಯಾವ್ ಇನಫ್ ಟೈಮ್ ಟು ಡೂ ಇಟ್ ನೌ ಬೈ ಯುವರ್ ಸೆಲ್ಫ್. ನಿಮಗೋಸ್ಕರ ನಾವು ಮಾಡಿದ್ದೀವಿ, ನಮಗೋಸ್ಕರ ನೀವೇನು ಮಾಡಬೇಕು, ನಮ್ಮ ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಬೇಕು. ದಟ್ ಈಸ್ ಪ್ಯೂರ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ವಿತೌಟ್ ಎನಿ ಇಂಪ್ಯೂರಿಟಿ ಆಟಮ್ಸ್, ದಟ್ ಈಸ್ ಇಂಟ್ರಿನ್ಸಿಕ್. Extrinsically they will be doped, mixed with that. The technical term is doped anta, doped with impurity atoms. Illi number of electrons equals number of holes in intrinsic. There will be no excess of either of them. But idralli electrons or holes majority carrier ಆಗಿರುತ್ತೆ, ಇನ್ನೊಂದು ಮೈನರ್ ಆಗಿರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ n ಟೈಪ್ ತಗೊಂಡ್ರೆ electrons will be majority, holes will be minority. p ಟೈಪ್ ತಗೊಂಡ್ರೆ holes will be majority. So there will be inequality in the number of them. Either one of them will be majority, one of them will be. So this has low electrical conductivity. So this has low electrical conductivity. And then this has higher electrical conductivity. Extrinsic semiconductor. So either purposely we create this extrinsic. Why? Because we need more conduction to happen. Adakoskara we do this. Idರಲ್ಲಿ silicon and germanium are pure conductors, semiconductors, intrinsic anta. If you add any trivalent or a pentavalent or any of these dopants, ಈ germanium ಮತ್ತು silicon ನೀವು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ you will get a mixed one which is impure, that is extrinsic. Very simple straight forward theory question ಇದು, ಈಸಿಯಾಗಿ ಬರೀಬೋದು. ಪಾಯಿಂಟ್ಸ್ನ ನೀವು ರಿಮೆಂಬರ್ ಮಾಡ್ಕೊಂಡ್ರೆ. on which factors does the conductivity of extrinsic semiconductor depend? So one is temperature. ಆಗಲೇ ನಾವು ನೋಡಿದ್ವಿ ರೆಸಿಸ್ಟಿವಿಟಿ ಮತ್ತು ಸೆಮಿಕಂಡಕ್ಟರು ಓಮ್ಸ್ ಲಾ ಲಿಮಿಟೇಷನ್ಸ್ ಬಂದಾಗ ಅಲ್ಲಿ ಒಂದು ಹೆಂಗೆ ವೇರಿ ಆಗುತ್ತೆ ಅನ್ನೋ ಒಂದು ರೆಸಿಸ್ಟಿವಿಟಿ ನೋಡಿದ್ವಲ್ಲ. ಅದರಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ, ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಸೆಮಿಕಂಡಕ್ಟರ್ ರೆಸಿಸ್ಟಿವಿಟಿ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆದಾಗ ಅದು ಕಂಡಕ್ಟಿವಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಟೆಂಪ್ರೇಚರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗೇ ಆಗುತ್ತೆ. ಆಮೇಲೆ ಡೋಪಿಂಗ್ ಕಾನ್ಸಂಟ್ರೇಷನ್. ಸೊ ಡೋಪಿಂಗ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂದರೆ ಟ್ರೈವೆಲೆಂಟ್ ಅಥವಾ ಪೆಂಟಾವೆಲೆಂಟ್ ಇಂಪ್ಯೂರಿಟಿ ನಾವು ಏನು ಡೋಪನ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಜಾಸ್ತಿ ನಂಬರ್ ಆಫ್ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಇರುತ್ತೆ. n ಟೈಪಲ್ಲಿ ವಿಲ್ ಹ್ಯಾವ್ ಮೋರ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, p ಟೈಪಲ್ಲಿ ಮೋರ್ ನಂಬರ್ ಆಫ್ ಹೋಲ್ಸ್ ವಿಲ್ ಬಿ ದೇರ್. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಕಂಡಕ್ಟಿವಿಟಿ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದ ನಂಬರ್ ಆಫ್ ಚಾರ್ಜಸ್ ಫ್ಲೋಯಿಂಗ್. ಸೊ ಜಾಸ್ತಿ ಚಾರ್ಜಸ್ ಫ್ಲೋ ಆಯ್ತು ಅಂತಂದ್ರೆ ಆಬ್ವಿಯಸ್ಲಿ ದಟ್ ವಿಲ್ ಬಿ ರಿಸಲ್ಟಿಂಗ್ ಇನ್ ಮೋರ್ ಕಂಡಕ್ಟಿವಿಟಿ. ಸೊ 2 ಪಾಯಿಂಟ್ಸ್ ಇಷ್ಟೇ ಸಾಕು, ನೀವು ಇನ್ನೇನು ಬರೆಯೋದು ಬೇಕಾಗಿಲ್ಲ. ಟೆಂಪರೇಚರ್, ಡೋಪಿಂಗ್ ಕಾನ್ಸಂಟ್ರೇಷನ್. ನೇಮ್ ದ ಮೆಜಾರಿಟಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಇನ್ n ಟೈಪ್ ಅಂಡ್ p ಟೈಪ್. ಆಗಲೇ ಹೇಳಿದ್ದೆ n ಟೈಪಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ, p ಟೈಪಲ್ಲಿ ಹೋಲ್ಸ್. ಸೊ ಹೋಲ್ಸ್ ಆರ್ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್. ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್ n ಟೈಪ್, ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ p ಟೈಪ್. ಆ ಥರ ಕೋರಿಲೇಟ್ ಮಾಡ್ಕೊಂಡು ಓದಬೇಕು. ಸೊ ನೀವು ಇದರಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಆಗಬಾರ್ದು. ಯು ಶುಡ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್ ವಿತ್ ದಿಸ್. ನೇಮ್ ದ ಮೆಜಾರಿಟಿ ಆ್ಯಂಡ್ ಮೈನಾರಿಟಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್, n ಟೈಪ್ ಮಾತ್ರ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಮೆಜಾರಿಟಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಆರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಮೈನಾರಿಟಿ ಆರ್ ಹೋಲ್ಸ್. ಆಮೇಲೆ ಅಡಿಷನಲ್ ಇದ್ರೊಂದು ಸಬ್ ಕ್ವೆಶ್ಚನ್ ಆ್ಯಡ್ ಮಾಡ್ತಾರೆ, ನೇಮ್ ದ ಚಾರ್ಜಸ್ ಫಾರ್ ದಮ್. ವೆರಿ ಸಿಂಪಲ್, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನೆಗೆಟಿವ್, ಹೋಲ್ಸ್ ಪಾಸಿಟಿವ್ ಅಂತ ಬರೀಬೇಕು. Draw a diagram of unbiased depletion region of PN junction showing immobile charges. So unbiased andre eno, biased andre eno, when you connect it to a supply battery, it becomes biased. Forward or reverse depends upon your connection. ಅದರಲ್ಲಿ p ಗೆ ಪಾಸಿಟಿವ್ ಆದರೆ ಫಾರ್ವರ್ಡ್, p ಗೆ ನೆಗೆಟಿವ್ ಆದರೆ ರಿವರ್ಸ್. ಅದೆಲ್ಲ ನಮ್ಗೆ ಬೇಕಾಗಿಲ್ಲ. ಅನ್ಬಯಾಸ್ಡ್ ಅಂದರೆ ಕನೆಕ್ಟಿವಿಟಿ ಇರೋಲ್ಲ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಹೋಲ್ಸ್ p ಕಡೆಯಿಂದ ಡಿಫ್ಯೂಸ್ ಆಗುತ್ತೆ, ಮತ್ತು ಎಲೆಕ್ಟ್ರಾನ್ n ಟೈಪಿಂದ ಡಿಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಎಲೆಕ್ಟ್ರಾನ್ ಡ್ರಿಫ್ಟ್ನ ನೋಡಿರ್ತೀವಿ. ಮತ್ತು ಈ ರೀಜನ್ ಏನು ಬರುತ್ತೆ, ಆ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಅಂತ ಕರಿತೀವಿ. ಅಲ್ಲಿ ದೇರ್ ವಿಲ್ ಬಿ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಅಂದರೆ ಮೆಜಾರಿಟಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸಲ್ಲಿ ಕಮ್ಮಿ ಇರುತ್ತೆ ಅಷ್ಟೇ, ಇನ್ನೇನು ಇಲ್ಲ. ಸೊ ಅದನ್ನು ನೀವು ಡಯಾಗ್ರಾಮ್ ಮಾತ್ರ ಡ್ರಾ ಮಾಡಬೇಕು. ನೋ ಎಕ್ಸ್ಪ್ಲನೇಷನ್, ನೋ ರೈಟಿಂಗ್, ನಥಿಂಗ್, ಓನ್ಲಿ ದಿಸ್ ಮಚ್. ದೆನ್ ವಾಟ್ ಈಸ್ ಮೆನ್ ಬೈ ರೆಕ್ಟಿಫಿಕೇಶನ್? ಸೊ ದ ಪ್ರಾಸೆಸ್ ಆಫ್ ಕನ್ವರ್ಷನ್ ಆಫ್ AC into DC is called as rectification. ಸೊ ಇದನ್ನು ಮಾಡೋದು ಪಿ ಎನ್ ಜಂಕ್ಷನ್ ಡಯೋಡೆ. ಸೊ ಅದರಲ್ಲಿ ಹಾಫ್ ವೇವ್ ರೆಕ್ಟಿಫೈರ್ ಇದೆ, ಫುಲ್ ವೇವ್ ರೆಕ್ಟಿಫೈರ್ ಇದೆ. ಸೊ ಅದು 5 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನಲ್ಲಿ ಬರುತ್ತೆ. ಅದು 5 ಮಾರ್ಕ್ಸ್ ವೀಡಿಯೋಲ್ಲಿ ನೋಡಿದಾಗ ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತೀನಿ. ಸೊ ನೀವು ಆವಾಗ ಅದ್ರ ಬಗ್ಗೆ ಡೀಟೇಲ್ ಆಗಿ ತಿಳ್ಕೊಬೋದು. ಹೌ ಕ್ಯಾನ್ ಎ ಸೆಮಿಕಂಡಕ್ಟರ್ ಡಯೋಡ್ ಬಿ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ಡ್? ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ದ ವಿಡ್ತ್ ಆಫ್ ದ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಎ ಸೆಮಿಕಂಡಕ್ಟರ್ ಡಯೋಡ್ ಇಸ್ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ಡ್ ಬೈ ಕನೆಕ್ಟಿಂಗ್ ವಾಟ್? ಅದರಲ್ಲಿ P, you remember P for positive, N for negative. P to P, ಅದೇ ಪಾಸಿಟಿವ್ ಟು P ಸೈಡ್, ಆ್ಯಂಡ್ N to N, ಅದೇ ನೆಗೆಟಿವ್ ಟು N ಸೈಡ್. ಇದು ಕೊಟ್ಟರೆ ಇಟ್ ವಿಲ್ ಬಿ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್. ರಿವರ್ಸ್ ಬಯಾಸ್ ಕೇಳಿದ್ರೆ ಏನು ಬರೀತೀರಾ? ಜಸ್ಟ್ ಆಪೋಸಿಟ್ ಆಫ್ ದಿಸ್. ಆಪೋಸಿಟ್ ಅಂದರೆ ಹೆಂಗೆ ಬರೀಬೇಕು? PN, NP. ಅದು ಹೆಂಗೆ? P side connected to negative terminal of the battery, N type or N side of the junction as diode is connected to positive of the battery. ಹಂಗೆ ಬರೆದ್ರೆ it will become reverse bias. ಸೊ ಇದನ್ನು ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಮಾಡಿದಾಗ ವಿಡ್ತ್ ಆಫ್ ದ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ವಿಡ್ತ್ ಆಫ್ ದ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಡಿಕ್ರೀಸ್ ಆದಾಗ ಕಂಡಕ್ಟಿವಿಟಿ ಬೆಟರ್ ಆಗುತ್ತೆ. ಸೊ ಫಾರ್ವರ್ಡ್ ಬಯಾಸಲ್ಲಿ ದರ್ ವಿಲ್ ಬಿ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್. ಪ್ರಾಕ್ಟಿಕಲ್ಸಲ್ಲಿ ಮಾಡಿರೋದಿಲ್ಲ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಕರ್ವ್ ಮತ್ತು ರಿವರ್ಸ್ ಬಯಾಸು, ಅದರಲ್ಲಿ ಓದಿರೋದು ನೆನಪಿದ್ರೆ ಈಸಿಯಾಗಿ ಬರಿಬೋದು ಇದನ್ನು. ಸೊ that is with all the 2 marks questions. ಸೊ ನಿಮಗೋಸ್ಕರ ಒಂದು 45 2 marks questions ತಂದಿದ್ದೀವಿ. ಈ 45 questions ನೀವು ತರವಾದರೆ ತರವಾಗಬೇಕು, ಒಂದು ಕ್ವಶನ್ ಬಿಡೋಂಗಿಲ್ಲ. ಯು ವಿಲ್ ಬಿ ಏಬಲ್ ಟು ಆನ್ಸರ್ 5 out of the 8 questions that will be asked. So we have done a lot of comparison and analysis and we have brought this to you. So you please subscribe to our channel Tej Academy to get timely updates on all the videos that will be uploaded to that. And you can also join our WhatsApp group. WhatsApp group ಅಲ್ಲಿ we will be putting messages that ಈ ವಿಡಿಯೋ ಅಪ್ಲೋಡ್ ಆಗಿದೆ ಮತ್ತು PDF ಅವೈಲಬಿಲಿಟಿ ಸಿಗುತ್ತೆ, ನಿಮಗೆ ಕಂಟೆಂಟ್ ಎಲ್ಲ ಸಿಗುತ್ತೆ. ಟೆಲಿಗ್ರಾಮ್ ಚಾನಲಲ್ಲೂ ನಿಮಗೆ ಅಪ್ಡೇಟ್ ಸಿಗುತ್ತೆ. ಜಾಯ್ನ್ ಆದರೆ ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಮಚ್ ಹೆಲ್ಪ್ಫುಲ್ ಫಾರ್ ಯು ಪೀಪಲ್. ಅಲಾಂಗ್ ವಿತ್ ದಟ್ ನೀವು ಗೂಗಲ್ ಪ್ಲೇ ಸ್ಟೋರ್ ಹೋಗಿ ತೇಜ್ ಅಕಾಡೆಮಿ ಆ್ಯಪ್ನ ನೀವು ಡೌನ್ಲೋಡ್ ಮಾಡಿದ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ಕಂಪ್ಲೀಟ್ ಆಕ್ಸೆಸ್. ವಿಡಿಯೋಸ್, PDF, ಕಂಟೆಂಟು, ಲೈವ್ ವಿಡಿಯೋಸ್, ಏನು ಇಂಟ್ರ್ಯಾಕ್ಷನ್ ಮಾಡಿದ್ದೀವಿ ಅದ್ರ ಬಗ್ಗೆ ಎಲ್ಲ ಮಾಹಿತಿನೂ ಸಿಗುತ್ತೆ. ಸೊ we have 2 days. 2 ದಿವಸದಲ್ಲಿ ಫಸ್ಟ್ ಯು ಪೀಪಲ್ ಪ್ರಿಪೇರ್ ಪ್ಲ್ಯಾನ್ ಆ್ಯಂಡ್ ಪ್ರಿಪೇರ್ ಮಾಡಿ. ಯಾರೆಲ್ಲ ಎಲ್ಲ ಚಾಪ್ಟರ್ಸ್ ಓದಿ ಯು ಆರ್ ವೆರಿ ಮಚ್ ಇನ್ ಟು ದಿಸ್, ಅವರೆಲ್ಲ ಚೆನ್ನಾಗಿ ರಿವಿಷನ್ ಮಾಡಿ. ಆ ರಿವಿಷನ್ ಆದಮೇಲೆ ಪ್ರಾಕ್ಟೀಸ್ ದ ಡಿರಿವೇಷನ್ಸ್, ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಯಾರೆಲ್ಲ ಈಗ ಒಂದು ಪಾಸಿಂಗ್ ಮಾರ್ಕ್ಸ್ ರಿಲೇಟೆಡ್ ಪ್ಯಾಕೇಜ್ ಎಲ್ಲ ನೋಡ್ತಾ ಇದ್ದೀರೋ ಈ ವಿಡಿಯೋಸ್ನ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ನೋಡಿ. 1 or 2 times if you read, if you see the videos, you will be able to get all the answers very well. ನಾಳೆ ಇವತ್ತು ಈ ವಿಡಿಯೋಸ್ ನೋಡಿಕೊಂಡು ಆ ಆನ್ಸರ್ಸ್ನೆಲ್ಲ ನೀವು ತರವಾದರೆ ನಾಳೆ 3 marksದು ವಿಡಿಯೋ ಬರುತ್ತೆ ಬೈ 11 o'clock ಅಥವಾ ಬೈ ಆಫ್ಟರ್ನೂನ್. ಆ ವಿಡಿಯೋನ ನೀವು ನೋಡಿಬಿಟ್ಟು ಮತ್ತೆ ನೀವು 3 marks ಪ್ರಿಪೇರ್ ಆಗಿ ಮುಗಿಸೋಷ್ಟಲ್ಲೇ 5 marks ವಿಡಿಯೋನ ಮತ್ತೆ ಇದು ಮಾಡಿರ್ತೀವಿ. ಆಲ್ರೆಡಿ ಫ್ಯೂ ವಿಡಿಯೋಸ್ ನಾವು ರಿಲೀಸ್ ಮಾಡಿದ್ವಿ 5 marksದು. 5 marks ಬರುತ್ತೆ. ಸೊ ನಾಳೆ 2 marks, 3 marks, 5 marks ಎಲ್ಲ ನಾಳೆ ಸಂಜೆ ಒಳಗಡೆ ತರವಾದರೆ ನಾಳಿದ್ದು ಅದನ್ನೆಲ್ಲ ರಿವೈಸ್ ಮಾಡಿಕೊಂಡು ಮತ್ತೆ ಎಲ್ಲ ಚಾಪ್ಟರಲ್ಲೂ ಆದಷ್ಟು ನಿಮ್ಗೆ ಎಷ್ಟಾಗುತ್ತೋ ಅದನ್ನೆಲ್ಲ ನೀವು ಓದ್ಕೊಂಡು ಒಂದು ಕ್ವಿಕ್ ಗ್ಲಾನ್ಸ್ ಮಾಡ್ಕೊಂಡು ಬಂದರೆ ಯು ವಿಲ್ ಬಿ ಮೋರ್ ಕಾನ್ಫಿಡೆಂಟ್ ಇನ್ ಅಪಿಯರಿಂಗ್ ಫಾರ್ ದ ಎಕ್ಸಾಮ್ ಅಂತ. ಡೋಂಟ್ ವೇಸ್ಟ್ ಯುವರ್ ಟೈಮ್, ಯುಟಿಲೈಸ್ ಯುವರ್ ಟೈಮ್ ವೆರಿ ಕನ್ಸ್ಟ್ರಕ್ಟಿವ್ಲಿ. ಯು ಹ್ಯಾವ್ ಟು ಬಿ ವೆರಿ ಪರ್ಟಿಕ್ಯುಲರ್ ಅಬೌಟ್ ಯುವರ್ ಪ್ರಿಪ್ರೇಷನ್. ಆದಷ್ಟು ಗಿವ್ ಮೋರ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಟು ರೀಡಿಂಗ್, ರೈಟಿಂಗ್ ಆ್ಯಂಡ್ ಪ್ರಾಕ್ಟೀಸಿಂಗ್. ಜಸ್ಟ್ ರೋಡ್ ಲರ್ನ್ ಮಾಡಬೇಡಿ, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡು ಓದಿ. ಅದೇ ರೀತಿ ಬರೀ ಬುಕ್ ನೋಡ್ಕೊಂಡು ಕೂತ್ಕೊಂಡ್ರೆ ಆಗಲ್ಲ, ನೋಡ್ದೇನೆ ಬರೀರಿ, ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. It will help you to learn easily. Don't get any kind of fear or phobia the ಬೇಡ ಫಿಸಿಕ್ಸ್ ಎಕ್ಸಾಮ್ ಬರ್ತಾ ಇದೆ ಅಂತ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡು ಓದಿದ್ರೆ ಎಲ್ಲ ಎಕ್ಸಾಮ್ ಈಸಿಯಾಗಿ ಬರೀಬೋದು. ವಿ ಆರ್ ದೇರ್ ಟು ಹೆಲ್ಪ್ ಯು ಆ್ಯಂಡ್ ಗೈಡ್ ಯು ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ಸ್. ನಿಮ್ಗೆ ಏನೇ ಡೌಟ್ಸ್ ಇದ್ದರೂ ಯಾವ್ದಾದ್ರು ಪರ್ಟಿಕ್ಯುಲರ್ ಟಾಪಿಕ್ ಕ್ವಶನ್ ಇದ್ದರೂ ಕೂಡ ಯು ಕ್ಯಾನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಸ್ ಥ್ರೂ ದಿಸ್ ಚಾನಲ್. ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಔಟ್. ಯಾವ್ದಾದ್ರು ಟಾಪಿಕ್ ಬಗ್ಗೆ ನಿಮ್ಗೆ ಏನೋ ಡೌಟ್ಸ್ ಇದ್ದರೂ ಕೂಡ ಇಫ್ ಯು ಫೀಲ್ ಲೈಕ್ ದಟ್. ಓಕೆ, ಆಲ್ ದಿ ಬೆಸ್ಟ್, ಪ್ರಿಪೇರ್ ವೆಲ್. ಸಿ ಯು ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ. ಬಾಯ್.